How does heat energy transfer from one substance to another? That's the name of this presentation. I'm your teacher, Mrs. DeBose, and take out a sheet of paper as you will have some questions to answer throughout this presentation. Put a full heading in the upper right-hand corner, first and last name, the period you have me, and today's date. Pause this anytime you need to. The nature of heat. Heat moves in only one direction. It moves from the warmer object to the cooler object. It will flow from one substance to another substance. That is, the warmer object will release its energy, its heat energy, until the two substances have the same temperature. Think of a hot cup of cocoa in a room. If you put that cup of cocoa in a room, you know if you leave it long enough, you come back and before you know it, it's no longer hot. It's room temperature. The room did not cool off the hot cocoa, but rather the hot cocoa was expending all of its heat energy trying to make the room the same temperature it was. However, of course, the hot cocoa didn't have enough heat energy to fill up the room, so it eventually releases all of its heat energy and evens out to be the same temperature as the room. Thermal energy is in the form of heat, can move in three different ways: conduction, convection, and radiation. We're going to spend the most time on convection. It's the most involved and kind of the one that takes the most thinking about to really understand how it works. Alright, so let's look at conduction. Conduction is a transfer of heat from one particle of matter to another by direct particle-to-particle contact. Conduction occurs in solids because the particles are so tightly packed together, and the particles themselves do not change positions. This is a demonstration of conduction. Remember, we said that conduction happens when matter is in a solid state, and this simply shows the particle-by-particle transfer of heat that is happening. Conduction. What are some other examples of conduction you can think of? I want you to describe the process of conduction when you place a hot spoon into a bowl of ice cream. Convection. Convection is the transfer of thermal energy or heat through the movement of matter. We know liquids and gases are matter, right? Well, convection occurs in liquids and gases or fluids. It doesn't happen in solids. Convection produces currents in both gases and liquids because they are fluid. And it carries, these convection currents carry the heat with them to other locations. This is why convection currents are responsible for weather. They carry temperatures to various locations across the globe. So in a convection current, what happens is that colder air or colder liquids, the particles are packed closer together, all right, and they become more dense. And when they become more dense, they sink. And as liquids or gases are heated up, those particles become further apart. They become less dense and they rise. So in effect, warmer liquids and gases rise up and cooler liquids and gases sink. Alright, so this is a demonstration of a convection current. Remember, we said convection happens when matter is in a liquid or gas state. So this is something we're very familiar with. This pot has boiling water in it. And it's the water right next to that heat source is becoming extremely hot. And as it heats up, it rises up. And as it cools down, it sinks down. As it heats up, it rises up. And as it cools down, it sinks down. Over and over again. Now you say, well, the water at the top of a boiling pot of water is still hot. Yes, that's true, but it's relative. In other words, it's cooler in relation to that water that's right next to the flame. Now that is very hot. This shows a convection current in the opposite way. This shows it with, first of all, a gas, air, because it's showing the inside of a freezer or a refrigerator. And instead of having a heat source the way the boiling pot of water does, did, this has a cold source. It has a freezer compartment. And that freezer compartment gets very cold. So you have air that is cooling down. And as it cools down, it begins to sink down. And as it gets further away from that cold source, it begins to heat up, and therefore it rises up. Remember, cold air is more dense, it sinks. Warm air is less dense, and it rises. Convection. Convection currents happen in the environment just like conduction can happen in the environment. Now, convection is different than conduction because conduction is by direct particle-to-particle contact. It happens in solids, whereas convection happens in liquids and gases. Convection is responsible for global winds that contribute to Earth's weather, of course, and is also responsible for ocean and lake currents. Like we said, convection happens in liquids and gases. So write number 1 on that piece of paper. Here's your first question. I want you to write about a time when you have experienced conduction. All right, so write number 1 in the left-hand margin, and I want you to give an example of a time you've experienced conduction. Let's work on filling in the blank. Wind blows from areas of to areas of. And we're going to use this picture here to help us. Now, over by the fireplace here, we have our low pressure air because it is hot air. Hot air is lower pressure. Heat up and rise up. Now, over here by the door, this is cooler air because it's not right by the heat source. And so this cooler air, remember, cool down, sink down, is our high pressure air. Remember, those particles are very close together. Now, as this air over here heats up and rises out of the way, it leaves an empty spot here, and that empty spot is perfect for this high pressure air just to come right in and take its spot. So heat up, rise up, and eventually it makes its way over here to this cool down, sink down, high pressure air, and then this high pressure air rushes in to take the place of this low pressure air that moved out of its way. So you have a convection cell or a convection current. You can't see it happening in a room, but it is. So wind blows from areas of high pressure to areas of low pressure. Now, the third method of heat transfer is called radiation. Radiation is how the Earth receives heat from the sun. Now, there are no particles between the sun and Earth, so it can't travel by direct particle-to-particle contact like conduction. Nor is it liquid or gas, so it's not convection either. But radiation is heat that transfers by electromagnetic waves. It doesn't require matter to transfer. Now, all the sun's energy is in the form of thermal energy by electromagnetic waves. All matter can radiate energy. Radiation. Some other examples of transfer of heat by radiation, which is transfer of heat by electromagnetic waves. You don't have to touch it directly, in other words. Here you go. And the last one, put number 2 on your piece of paper. I want you to come up with one that you can think of. What type of experience have you had with radiation? When have you felt heat by radiation? In other words, you're not directly touching something. The heat is just coming off of that item and you're feeling it. Here's number 3. So write number 3 in that left-hand margin. When you put a teapot on the stove to boil water, which of the 3 kinds of heat transfer can be observed? I want you to write your answer. Be careful. This may be a trick question. Lastly, here's some examples of conduction, convection, and radiation. Take a moment to read through all 3. And if you made it this far in the presentation and you've been reading carefully, which I hope you are now, and you've been paying attention, I want you to go ahead and write down the word maple syrup. Actually, it's 2 words. But write that at the bottom of your sheet, maple syrup. Thank you, and be sure to bring your homework in tomorrow for credit.